Hello, class. I hope this will be better for you because I've been trying to add my voice to the presentations, and so far we haven't had any luck. But now I think we're going to have a different view of what goes on. Now, of course, we are still working with the same model, G, that is titled Space. The unit is 2, the solar system, and the lesson 1 is historical models of the solar system. Please follow up with me on the next slide so we can get to know what are our learning objectives for this lesson. Learning objectives. First, the solar system overview. We have to know or define what a solar system is. How do we define it? Of course, it's very simple to us now. We know these things, but we have to define them either way. The most interesting part is the two words geocentric and heliocentric. So these two words represent two models of the solar system that we will get to know in the next slides. Now, more about the solar system is the early theories of how scientists described the solar system. Namely, two scientists. We're going to study the views of two scientists in these slides: Aristotle's explanation of the universe and Aristarchus's view of the solar system. Now, both of them are different, and we're going to see how different. Now, and we're going to define along the way the word parallax. What is parallax? We're going to get to know it and, of course, define it. What is the center of the solar system? A question that made a lot of scientists since the Greeks to wonder about. But before we answer that question, there is the question that is simple. What is the solar system? So we can talk about the center of the solar system. We need to know what the solar system is. The solar system is the sun and everything that revolves around it. That's what we know today. Today, for us, the solar system is the sun and the planets and the moons and the asteroids and the objects and the bodies, the dwarf planets even, that all revolve around the sun. That's what we know today. Our solar system, or our current view of the solar system, or model, we say, is a solar system with the sun at its center, or we say sun-centered. A word for that is heliocentric. Helio means sun, and centric, of course, means center. So the sun is at the center of our current model of the solar system. And of course, in the heliocentric model, Earth and all the other planets orbit the sun. Not just the other planets, all the other celestial bodies that are out there, okay, next to the sun, they all orbit the sun. Now, in the earliest days, let's say since the Greeks, people thought that because Earth, we wake up every morning on Earth and we look at the sky and we see the sun go up and then go down during the day, and then the moon comes up in the night, and the other stars and the other celestial bodies, and they also go down, and then the sun comes up again. Well, obviously, it seems that for us, from our perspective, from our point of view as humans living on Earth, everything is moving around Earth. And so it was widely accepted that the Earth is not moving, and it is the center of the universe, and everything is just turning and revolving around it. That makes that model, or that created an idea, okay, to name that idea, where the Earth, of course, is at the center of the universe, not just the solar system. This is what caused scientists to say that Earth is at the center of the solar system, and the Earth-centered model of the solar system, or geocentric model of the solar system, was thus created. Now, of course, a lot of scientists thought that way, and some of them didn't. Now, the heliocentric model that we are using today, it was not accepted at all by scientists throughout the ages, all the way to the 15th and 16th century, and to the early 17th century, until scientists started proving that the heliocentric model is the one that is correct, and not just the geocentric model. So the geocentric model presented certain flaws, while the geocentric model explained everything correctly and the way we see it today. Now, who were the scientists? Two names come up, of course, in the 16th and 17th century that did a lot of work and presented a lot of proof about the heliocentric model. Those are Copernicus and Kepler. Moving on to the next slide. Who proposed some early models of the solar system? I remind you, we say early models. The early models of the solar system, of course, as we just mentioned before in the slide before this one, were geocentric, right? And so we're going to go back and see more about the geocentric model. Now, Galileo came to improve the telescope in 1609, but people before that did not have telescopes or anything else to see the stars with except their eyes. And so using their eyes wasn't actually such a very good technology, but for them, for those observers, it appeared that the sun and the moon and the planets and everything, all the celestial bodies, the stars, they moved around the earth each day, as we said before. And that's what caused them to say that earth was the center of the universe, not just the solar system, okay? And everything in the universe is revolving around earth. That, as I said before, created what we call the geocentric model, an idea for scientists to work with. Of course, something had to be, let's say a pattern had to be drawn on that, and of course they chose that common idea of the earth being the center or at the center of the universe. It made the humans think that they are also the center of attention and center of the universe. Okay, and so the geocentric model of the solar system, it became a part of the ancient Greek beliefs and thoughts beginning in the 6th century before Christ, of course. And the Greek philosopher Aristotle was no different. He was of the first thinkers that came and proposed the geocentric model of the earth and at the center of the solar system and everything else revolving around it. In this model, of course, he placed the moon, the sun, the planets, as we said before, in a series of circular paths or circles around the earth. Okay, and they are, or all the planets and the sun and the stars and other bodies in the solar system are just revolving in circular paths around the earth. Well, Aristotle thought, what if, in addition to that, what if the earth is also moving? If the earth was moving, then there has to be a shift in the position of all those stars. They're going to look differently, and I'm going to have some kind of shift of their view, because every time an object moves, there would be a different side of it to see, right? That's what makes things even more difficult to explain, more difficult to work with. But Aristotle had a name for that. He said that this apparent shift in the position of an object, when it is viewed from different locations, and when I can capture different views of that same object, we call that parallax. Now, of course, stars were very, very far away, and he did not have any telescopes to view these stars, so the parallax for stars was actually non-existent because they were so far away. And the parallax, of course, was not seen. I can't see a star that is very, very far away in different views, even if I am moving. So that was Aristotle's point of view. On the other hand, I have Aristarchus's point of view that said that we have a heliocentric model of the solar system. Heliocentric means that the sun is at the center, and that was a major shift in let's say the way scientists and the community back then thought. Of course, that made a lot of controversy, and that caused Aristarchus a lot of problems, that he did not actually want to pursue that. Well, who is Aristarchus actually? Aristarchus is a Greek astronomer and mathematician, and he did propose the heliocentric heliocentric model of the solar system. As I said before, it was refused, and it was unaccepted, and it was thrown away, and he did not actually stand his ground and defend it. But on the other hand, he did get busy working on other things, other contributions to science that allowed him to have his own stature as a scientist. Like, for instance, he contributed a lot measuring the distances between the moon and the sun. Our last scientist for today we're going to talk about, who worked also on the geocentric model, is Ptolemy. Ptolemy was living in Alexandria, Egypt, and he is an astronomer, or was an astronomer, geographer, and mathematician. And also he was also like a bookworm, if you want, and he gathered information and observation about all the planets that scientists ever studied before his time. He went back as far as 800 years before his time to gather all that information and all the observations about planets, and he put them down into one single model, geocentric model. And his model was very detailed and was very appreciated by many scientists, that they adopted it. By astronomers, they adopted it, and they agreed to use it for 14 centuries ahead. Now, Ptolemy's model of the geocentric solar system had, let's say, a lot more details than before, and he explained that these planets, although they move around the Earth, they also are moving in their own circles. And so he called this, or many called his model, the wheels on wheels model. Okay, and as you can see in the picture, that the Earth is at the center, and the wheels on wheels system says that each planet must be moving on its own small circle. At the same time, it is also moving along a bigger circle, the purple circle, that is going around the Earth. As you can see, I have the only ones that do not show that are the moon and the sun. They do not have their own circles, and that raises a question. Also, another question that could be raised is, why are these planets circling like that? What are they circling? What's at the center of that circle? And so other scientists came along later on to study these things further and to put the Ptolemy geocentric model, the very important model, to the test, and they came out with another model that they called heliocentric, and that is for our next session to discuss. Okay, thank you for following up, last information about why Ptolemy's model was so appreciated. It's because it allowed people to predict the motions of planets years into the future, and so that was also a very important, let's say, part of Ptolemy's geocentric model, the wheels on wheels model. However, on the next session we will get to know more models. Let's say another model, the heliocentric model, that was developed by many other scientists that came along, and as I said before, they put Ptolemy's model, wheels on wheels, onto the test, and they found out that there are a few little things that did not actually make sense, and so they suggested another model that of course explained these things and explained all Ptolemy's findings as well. So they didn't just wipe out Ptolemy's model, no, they improved it into a heliocentric model. Thank you for listening. It was quite a lesson, and I hope that you got a very clear idea of what a geocentric model is. On the next presentation or video, we will tackle another set of objectives, and we will get to know more scientists and more of their work on the solar system's model. Thank you for listening, and thank you for your undivided attention. Please stay safe, and see you next time.